Good morning. Today we are going to discuss how to overcome a race condition in JK flip-flop. In the previous class we have discussed how this race condition is happened. That means if the propagation delay is less than t by 2, that means the period of the clock cycles, let it be t. Then if it is less than t by 2, then definitely the output of this will toggle like this. That means it will go like this. That means 0 1 0 1 etc etc. That means during the same clock period it is changing. It is changing from 0 to 1 to 0 to 1 to and something like that. Okay, that is called a race condition. Toggling means you are just changing. If it is from 0, it is changing to 1, and if it is 1, it is changing to 0. It is called toggling. And racing means this, it keeps on changing the value 0 1. So that means no control over it. We have no control over it. So how to overcome this race condition? There are three methods, and now we are going to discuss this method. That means here the first method is you have to keep this t by 2. That means clock cycle. Your clock cycle should be less than propagation delay. That means half of the clock cycle, half of the period of the clock cycle should be less than the propagation delay. That is impractical. That means impractical. So we are not using this method, and now we are not discussing that. Use edge triggering. Use edge triggering is another method. Edge triggering we can use another use that technique. And now we are focusing on we are going to have a master slave JK flip flop. That means instead of having a JK flip flop, we are going to have two JK flip flops one by one, and we have something like that, and we are going to discuss master slave JK. Master slave JK flip flop. See, this is a JK flip flop, and I am going to attach one more JK flip flop to this. Here I am attaching one more JK flip flop. That means again here we have a NAND gate. NAND gate. Now here you are having a NAND gate. Here you are having another NAND gate. These are all NAND gates. Now here this is the output. Here this is the input, and this is the output. Now this is connected like this, and this is connected like this. Okay. Now the output of this is fed as the input to this, and the output of this is fed to the input of this. Okay. Now what will happen? Here we are not having any feedback from here to the input. Here also we are not having any connection like this. Now what I am going to do is, here this is Q and this is Q bar. Now Q bar is fed as the input to this clock, input to this NAND gate, and this Q bar is fed as the input to this NAND gate. Okay, now one more thing is left. That means here you have a clock, and now you have a clock, and now this clock you have to feed this clock like this. Okay, now what you are going to do is, this is you are going to give complement, and that means clock bar. That means this is clock, and here you are going to provide clock bar. That means you are complementing that here. That means here this is the clock, And if this clock is 0, that will be 1. And if this is 1, that will be 0. And like that. Here, this is the J input. This is the K input. J is input, K input. And we are not bothered about these values. Okay. Now, we will discuss. This is the master slave JK flip flop. That means this is one JK flip flop and this is another JK flip flop. Okay. Now, why this is called master slave JK means this, if you are giving clock input as 1, this JK flip flop is operative, and at that point in time this will not operate. And if this clock is 0, what will happen? This won't work. That means here this is the master flip flop and this is the slave. And this master is working when the clock input is 1 and this is working when this clock pulse is 0. Okay. Now, how this is working, we are going to discuss that. Now we are going to discuss the operation of master slave JK flip flop. As you know, here this is acting as the master and this is acting as the slave. This is acting as the master and this is acting as a slave. And see, here this flip flop master is working on positive clock and the slave is acting on or this operation on the negative clock. For example, suppose that here this is the clock. Okay. Now during this period, that means initially during this period master is active and during this period slave will be active, and here master is active and here slave is active. Okay. Now J is equal to 1 and K is equal to 1. I will show you what will happen for this Q. Suppose that initially Q is equal to 0 and Q bar is equal to 1. What will happen? We are going to discuss that. Now, say if Q is equal to 0 and Q bar is equal to 1, and during when this master is operational, what will happen? The previous value of Q is 0 and here the input is 0, and the previous value of Q bar is 1, here it is 1, J is equal to 1 and clock is equal to 1, and these are the values here. Now during this period, during the initial period, this master is active because clock is directly given to the master and clock bar is given to the slave. Now when this master is operational, what will happen? 1 and 1 is 1 and this is 0, and 1 and 1 and 0 is 0 and its complement is 1, and if you take, that means here whatever be the input here, whatever be the input to this, as it is 0, 0.0 or 0.1, that means whatever be the value of this input, the output of this will be 1. That means 0.0 or 0.1 again 0 and it is complemented and 1. Here definitely the input here will be 1 and 1.1 is 0 and the output will be 1 and here it is 1. That means now this is stabilized. That means 1.1 is 1 and this will be 0 and 0 is for here and 0.0 is 0 and 1 and now it is stabilized. That means after the operation of the master, the input to these two will be 1 and 0. 1 and 0. Okay. Now, when after this period, when it is switching to its negative edge, what will happen? This will become active. this will become active. Now what will happen? What will happen? The input to this is clock bar means here it is 0 and clock bar is 1 and 1. Then what will happen? 1 dot 1 is 1 and output will be 0 and this will be 1. And what will happen? If this is 1, definitely whatever be the value of this input, 0 dot that input is 0 and the output is 1. Now this is changed to 1. Okay. Now when this is 1, what will happen? This will be 1. 1 dot 1 is 0 and 1 dot 1. 1 dot 1 is 1 and it's complemented. That means this will become 0. That means when this is 0, that means initially the value of this Q was 0 and after the operation of the master and the slave, now that value has been changed to 1. That value has been changed to 1. That means in a single clock cycle, first for half of the time the master is operating and for another half of the cycle the slave is operating, and after the operation of the master and the slave, this value has toggled. That means complemented. That means this value was 0 and now it is 1. This value was 1 and now it is 0. Now that is fed as the input to the master, but as this is the negative edge, now this master is not operational and master is active only when here, that means positive edge is coming. That means during this period again this master will be active. Then we are going to discuss what will happen. That means now the input is 1. That means during the next, that means here, suppose that this is Q. Up to this point, initially this is 0 and this is 1. And initially the value was 0. And when this master was operating, this was 0. And after the operation of the slave, this becomes what? 1. That means here during this period no change, and after when the slave is operating on this becomes 1. And now what will happen if again the master is operating? That means now the input here is 1. And input to this is 0. Then what will happen? 1 dot 1 dot 1 is 1 and the complement is 0 here. And 1 dot 1 dot 0 is 0 and its complement is 1. Now this is 1. And whatever be the input here, you are feeding here, as it is 0, this will be 1. And that is fed to this input. 1 dot 1 is 0 and this definitely that will become 0. Okay. Now that is 0 and the input to this slave is 0 and this is 1. Okay. Now there is no change for Q when the master is operating. When the master is operating, there is no change. When the slave is operating, what will happen? When the slave is operating, here 1 dot 1 is 1 and this complemented, this will become 0. And 1 dot 0 is 0. When this complemented, this is 1. Okay. Now see, whatever be this input, as this is 0, definitely this will be 1. That means now this has changed to 1. As it is 1, here you are feeding 1. 1 dot 1 is 1 and the complement is 0. Now it is 0. That means again it is complemented. That means when this slave is operating, now it becomes 0. Now it has changed to 0. Then that 0 is for, that means during the next master slot. This is master. This is the first half of the cycle is for the master, and for the next cycle it will be for the slave. Now slave is operating, and like that here we are having a graph like this. That means now in this way we have eliminated or we have overcome this race condition. That means, in short, if you are using a master slave JK flip flop, if the value of J and K are 0, 0, 0, 1, 1, 0 and 1, 1, what will happen? The value of Qn plus 1, that means for the next cycle, what is the value of Qn? That means J and K are 0 and 0 will happen. The previous value it is storing, that means Qn. The previous value it is remembering, that means there is no change, it is retaining the previous value. If it is 0 or 1, this is the next value will be 0. If it is 1, 0, it is 1, and this is 1, 1, it is Qn bar. That means it is complementing the previous value. That means Qn is remembering. Remember, this is a reset. This is setting the value, and this is complementing. That means you should note this point. If you have a JK flip flop, and that JK flip flop is operating, that means it is operating the positive. It is level triggering on the positive edge, and if the clock is 1 and the value of J and K are 0 and 0, it is retaining the previous value. That means it is storing or it is remembering the previous value. If it is 0 or 1, it is resetting. That means that Qn is set to reset to 0, and if it is 1, 0, Qn is set to 1, and if it is 1, 1, what will happen? It is complementing the previous value. That means there are 4 operations. One is remembering or storing, then setting, resetting and complementing. That means these are the 4 different types of operations as far as JK flip flop is concerned. Now suppose that initially we have a notation like this. Simply we are having a JK flip flop like this. This is a flip flop. This is the JK flip flop. This is JK, and this is the clock. And these are the outputs Q and Q bar. This is the JK flip flop. That means if the value of J and K are 0 and 0, and if the input, if this clock value is 1, what will happen? This Q is the previous value. If J and K are 0 and 1, this Q is reset. If J and K are 1, 0, then this will be set, and if J and K are 1 and 1, this complementing this value is complementing this value. That means 4 operations are there: stores, reset, set and complement. Okay. Now what is T flip flop? What is T flip flop? That means here we are shorting this J and K. That means this T flip flop was only one input. That means this is, that means if you are shorting this, that means here that is T. That means this is T, and this T value is J and K are shorted. That means whatever the value of J. That means now here for this you have only 2 possibilities. If you put J here, then JK will be 0, 0 or JK will be 1, 1. Then this is called T. That means if you are giving T as 0, what will happen? If you are giving T equal to 1, what will happen? That means The truth table is like this. The value of t is this. Then the value of j and k will be this, and the q value is this. That means if it is t is 0, what will happen? J and k are 0 and 0. If this is 1, 1, 1. And if j and k are 0 and 0, it is remembering the previous value. Remember. And if it is 1, 1, it is complementing the previous value. That means for a T flip-flop, it can do two things. Either it can store the previous value or it is complementing the previous value. Either stores or complements. Either stores or complements. Those are the functions that can be done for a T flip-flop. That means T flip-flop is same as JK flip-flop, but the J and K terminals are shorted. That means if you only one input is given to both the terminals, same input. That means either it is 0, 0 or 1, 1. If it is 0, 0, what will happen? It is remember the previous value, and if it is 1, 1, it is complementing the previous value. Okay. Now, what about D flip-flop? It is also a variation of this JK flip-flop. It is also a variation of JK flip-flop, and that is, instead of shorting this, you are complementing this value as given to the other one. That means it is given after complementing. That means whatever you give as input to this J, here K will be its complement. That means if that is this is D, this is J, and this is K, then D is 1. That means if 1 is given, then J is 1 and definitely K will be 0. If D is 0, then definitely J will be 0 and this is 1. That means D flip-flop means you are giving two inputs to J and K, and one is the complement of the other. That means 0, 0 and 1, 1 are complemented. Either it is 0, 1 or 1, 0. Either it is 0, 1 or 1, 0. That means if it is 1, 0, then the value of Qn will be set, and if it is 0, 1, this will be reset. Okay, that means either sets or resets. Either sets or resets. So that's all about 3 different flip-flops. That means until now we have been discussing what is an SR latch, what is an SR flip-flop, then what are the limitations of SR flip-flop. Then we studied JK flip-flop in detail, race condition in JK flip-flop. Then we discussed what is master-slave JK flip-flop and how JK flip-flop can be converted to either D flip-flop or T flip-flop. That also we discussed. So with this we have a number of applications and counters, registers, everything. That means you can see every circuit. If it is an electronic circuit, you have to use these techniques. Flip-flop is a very important point, or flip-flop is a very important component as far as digital electronics is concerned. So with this I am concluding this session. Hope you have enjoyed this session. Thank you.